Hello, my name is Kay and I'm going to demonstrate my hand. The first thing is this is standalone 6x1.5 battery to be connected into the power supply board. I hit the interrupt key to get the hand in neutral position. From about the power supply, the Arduino mega board is powered directly from the 5-volt regulator onto the 5 volts via this piggyback board. Now I shall demonstrate the signs in fast mode, starting with sign I. Now sign L. And it's all controlled by these switches here. I press a button for the speed, fast speed, button for slow speed, and an interrupt button that puts the hand to neutral position. If there is a noisy motor, I just hit that button and it sets it to neutral position. I shall continue demonstrating in fast mode with sign Y. Sign W. And just to demonstrate the interrupt key again, it will interrupt this task of sign W and go back to default position, then go back to its task that it was interrupted. Now sign V, fast. Now I shall go through the signs in slow speed, starting with sign I. Slow speed, sign L. Hit interrupt, it immediately springs back, then it goes to on with its previous job, which is completing sign L, slow. Interrupt to set it to default. Sign Y, slow. Sign W, slow. I'll hit the interrupt just to display the function. It goes back to completing its task. I'll do W again. Uninterrupted. 3. Interrupt to stop the rattly motors. Sign V, slow speed. When it came to making the digits, I cut a slot in the digit after cutting the dowels to appropriate lengths. Then I cut these T-hinges, just cut them there and there to have a round bit and a square bit. We just go into the dowel slot, then the other one This was milled out by the lathe, would go in like this. Relatively good fit. Of course I'd adjust the lengths and everything, but that would be the heart of the movement. And then I'd epoxy these in. This was aquarium tube, length of aquarium tube 10mm. I cut it in half to act as the dowel joint. So I could always put that down there. And then just the elastic glued across like this. So you get the idea, and would slot in. The whole bit was then attached to a block where the horns of the servo motors are milled out a bit there. The horns of the servo motors would go in. Like so. And the elastic would come along and run on top of the block, or a better angle like this, and this block would pivot with the servo horn and the digits are attached. So that's the whole issue of the solution, was how to hold it all in tension, and the elastic held it straight when the fishing line was not pulling it downwards, and it could return to a neutral position once fishing line was released. These plastic bits acted as a path for the elastic to flex along to stop it falling in between the joints. So the thumb, this one here, and these are dress hooks. I just drilled into the dowel, and that created a path for the tendons. With the interrupt is a hardware to bounce switch, because I didn't want to put a software to bounce within an interrupt loop. So what happens, the switch is pressed, it comes into a Schmidt trigger inverter and goes through two gates, and the output of this chip puts it into interrupt 1. The code. We've defined the button ports for 7 buttons. We've set up 1 interrupt, and I've set up 10 registers for pulse width modulation, so there's 10 timers involved. And the button outputs are also set here as well. The void loop just simply consists of a couple of variables, a case statement for the 5 signs fast, and another case statement for 5 signs slow. Within the case statement, they call upon a function. Each function is user defined for a hand sign. So I'll just scroll down here and show you the interrupt. The interrupt just makes a neutral sign position. That's the service routine. The slow hand sign function has a delay loop between the start and the destination of each finger, of where each motor goes to. And it's the same for all slow functions. The fast functions, this one here for example, has 4 motors moving the fingers for a sign. It delays the servo for about 25 milliseconds, then it returns to original position, and thus for the rest of the 5 signs. We go down here to a function of button is pressed. Each button will return an integer, and for a given integer it will give a different sign. There are actually 5 buttons for 5 signs, and the 6th button and 7th button is for fast speed. The 7th button is for the signs to go through at the slow speed. The 8th button up here, and it activates the interrupt service routine.